Assalamu alaikum students. It's our 11th lab experiment of OOP and Data Structures lab. The title of the lab is Familiarization, Implementation and Usage of Stakes. In this lab, I will tell you about what is meant by stake and how do we implement the stakes using arrays and linked list. So, coming to the list of labs which we have already done in the OOP and Data Structures, we have done 10 labs in it, and it's our 11th lab and third lab of data structures. So the objectives of the lab are to familiarize the student with stake implementation using arrays and linked lists. That how you will implement the stake using the arrays methods or the linked list. So I will implement a code of stake using array, and also will implement a code of stake using linked list. So coming towards the stake, a collection of elements arranged in a linear order. If we took an example of the real life, so in real life, the stake of books, the stake of plates, the stake of folded clothes, in these kind of stakes, if we take the example of plates, so we took the plate from the top and also insert a new plate or put a new plate on the top. So it follows the LIFO, last in, first out. The last item which you put in the stake, you will remove it first. So the new items are added at the top of the stake or remove them from the top and can access the elements of the stake at the top. So the following are the some of the important methods used for stack. As for inserting elements, you will use the push function, and for removing the elements, you will use the pop function. If you insert any element or remove any element, so the top will take care of it. It will take the record that if you remove any element or insert element, so the top will be changes. For example, if you are insert a new element, so the top will be pointing to that element. If you remove any element, so the top will point to the topmost element. So the push function, the push method will take an element and insert it at the top of the stake. These elements will become top element. The pop method will remove the top element of the stake and return it to calling program. The top method returns the topmost stake element but does not remove it from the stake. It will just tell you that which element is on the top. It is not in the function of removing or inserting anything. It will just tell you that which element is at the top, because if you want to insert any element, so it will increment. If you are removing any element, so it will decrement. So at the start, if we look at the diagram, at the start the stake is empty. As this stake is empty, push the value 2. So it is inserting a 2 element in the stake, and as a result the number 2 is placed in the stake as we are pushing 2. The top pointer points at the top element. The top pointer is pointing to the top element. Then push 5. Then we have insert another element 5. So the top pointer is pointing now the new element which we have inserted. The number 5 is placed at the top of the number 2 and pointer top moves one step upward. As you insert elements, so the top pointer will increment, and if you remove any element, so the top element pointer will decrement. Then push the number 7. So in this examples, first the stake was empty, then we have insert 2, 5, 7, 1 elements, and they are inserting one by one, and like this the top element is also incrementing. As in the last is the last element which we have insert, So the top element is pointing to the last inserted element. Now coming towards the next example, in which we have also a pop function and a push function. Now pop the element from the stack, the first figure of second row. As this is the pop, so the pop is 1. We have just 1 to it, so it is the continuation of this. 1752. We have popped the one element as we have removed the one element. So here the top is decremented and it's come towards the 7. Here we have pushed 21. So the top is incrementing to 21. And if pop 21, so the pop means that you are removing any element. And then pop 7, so the pop 7 is also removed and the top is decrementing. And then at the end 5 pop, so the 5 is also removed, so only two second element is left in the stack, and the top pointer is pointing to the this element. So you have to insert elements at the top and and also remove from the top. This is the main concept of the stack. LIFO, the last element to go into the stack, is the first to come out. That is why stack is known as a LIFO, last in, first out structure. Mean it is if you came to know that what is LIFO, so you can say that the stack is working on the LIFO structure. So if you want to implement the stack using array, so the stack can be implementing using an array. The interface will remain as push and pop methods. You will use the same push and pop methods, but the user of the stack doesn't need to know that the stack is internally implemented with the help of array. As you have implemented the code, so the user will not aware of that which method you have used to implement the stack. The worst case for insertion and deletion from an array may happen when we insert and delete from the beginning of the array, where the elements must be shifted to the right for insertion and left for removal. In this case of push, the elements of the stack must be shifted to the right, while in case of pop, the stack element must be shifted to left, where we remove elements. By pushing the elements at the end of the array, there is no need to shift any elements. Mean if you want to insert or remove at the beginning, then shifting will be happen, but if you are pushing elements at the bottom, so there will be no shifting. Similarly, as the pop method removes the last element of the stack, which is at the end of the array, no element is shifted. To insert and remove elements at the end of the array, we need not to shift its elements. Best case for insert and delete is at the end of the array, where there is no need to shift an element. The best way to implement push and pop by inserting and deleting at the end of an array. The stack can be shown as an array in the following figure, where top is equal to 3 at element number 1. So here is the figure. Here we have the figure, the 2571, and top is pointing the 1. So as array, it's the size of 5. So the top is at 0, 1, 2, 3. The top is at 3 position. So here at 3, the top is equal to 3. Because here the last element, the top is pointing the last element. Now I will implement this code for you in the def compiler, and I will show you that how you will implement the code in the def. So I have included the headers, iStream, and using namespace SDT. Then I have make a class of stack using array, and I have mentioned the private sum members as the array of elements 5, and this is the index of array. and then a size also. Then I have this is the constructor in which we have assigned the index of array -1. So if you assign it a -1 value, so mean there is no element in the stack. The stack is empty. Because if you want to create a stack, so first you will check that either the stack is empty or not. So the index of array is equal to -1. This means that the stack is empty and the size of the array will be 5. Now if you look at the in the first, I have just declared the three things: the index, and mention the array of 5 elements, and then the size, and then simply coming towards the push and pop functions. So in the push function, you have to just simple increment the index, and it will be saved in the X, while in the pop you have to just decrement, and the top will be the index of array. Mean if you are inserting an element, so it will be incrementing, but if you are popping an element, so it will be decrementing, and the top will give you the last position. If you are inserting an element, so it will give you that position. If you are removing an element, so it will give you that. So this was our class. I have ended with this semicolon. This function is used for inserting elements to stack through array, and this function is used for removing elements one by one. So first in the program, in the start, first we consider that the stack is empty, and then you will implement the push function, and then the pop function, and the top function. The top function will give you that now where it at which element the top is. So coming towards the main, I have create a object st with the name of the class. The size is 5, as we have already mentioned in the class. So here first you have to push the elements. For pushing the elements, simply you will call the push function and apply the loop, that how many elements you want to insert or push in the stacks. And here are the elements, that how many elements you want to remove from the stack. So in the both cases you will implement it by using loops, that first the 5 elements will be inserting, and then it will be popping the elements. So here it will show you the pushed elements, and it will show you the popped elements. So coming towards the output, so here you have 5 elements. So the push elements are 0, 1, 2, 3, 4, and as you know that while popping or removing, the last element will be removed first. So the last element in the stack was 4, and so here the 4 is removed first, and then 3, 2, 1 and 0. So here was the implementation of stack using array, and hope that you will have no problems in it, and if still you have any problems, so we can discuss it in the interactive session. So now coming towards the stack, that how you will implement a stack using linked list. In implementation of stack using an array, a problem occurs, which is the size limitation from array side. The problem can be avoided by implementing stack using linked list. There is no need of current node, as insertion and removal of elements in stack using linked list is from top, that is the head node. Therefore, it makes sense to place stack elements at the start of the list, because insertion and removal take constant time. as we don't need to move back and forth within the list. Therefore, there is no requirement of doubly or circularly linked list. So you have to only implement the stake using the single linked list, as you have to remove and add the elements at the top. So you have to only do with the top pointer and the push function and the pop function. Hence, the decision is to insert the elements at the start in the implementation of push operation and remove the elements from the start in the pop implementation. So you have to knowledge of the top, that which is the top pointer, that which will be the pointing to the top, or the last inserted node. So and you have to insert the elements using the push function while remove the elements using the pop. So here it is the example of stake, that how you will implement this using the linked list. So it is the head pointing the first node, and the nodes will be having the data and the pointer pointing to the next node. So here is the example of the linked list, that how you will implement the stake using linked list. So here is the first element, and the first element is the first node, as the head will be pointing to the first node. So here the head will be act like a top. So in the linked list, the head will be just like a top, and it will be the first element inserting, the 2 will be the first, then the 5, then the 7, and then at the end the 1 element. So there are two parts of figure. On the left hand, there is the stake implementing using an array. The element presents inside the stake are 1, 7, 5, 2. Here the elements are 1, 7, 5, 2. The most recent element of the stake is 1. It may be removed if the pop is called at the point of time. On the right side, there is the stake implementation using a linked list. This is the stake implementation of linked list. The stake has 4 nodes inside, in which are linked in such a fashion that the very first node pointing by the head pointer contains the value 1. The first node with the value 1 is pointing to the node with value 7. The nodes with value 7 is pointing to the node with value 5, while the node with value 5 is pointing to the last node with value 2. To make a stake data structure using a linked list, we have inserted new nodes at the start of the linked list. When you are creating a stake using the linked list, so you have to just insert a node at the start. So if we look at its algorithm, so in stake we have two main functions, push and pop. Following is the pseudocode for both. So the push function is that here is the stake in any array with the max location. Top points to the topmost element and item is the values to be inserted. So if the top is equal to max, then print overflow. For example, if you have a stake and it is full and you want to insert any elements, so you have to check the top first, that either the top is if the top is equal to max, so it will print overflow, else the top will increment by 1, and thus the top stake top, and that item will be assigned to that stake top and item insert. If the top is at maximum, so it will print the overflow, that there is no need to insert elements. But if there is a space in the stake, so the top will be simple incrementing. And now coming towards the algorithm of the pop. So here the stake is an array with max locations, top points to the top. For example, if top is equal to 0, if the top is pointing to nothing, so that there is nothing in the stake. So you can't remove elements from the stake. else item, or in the other case, if it has elements, then top pointer will be assigned to the last element, and the top will be incremented and the item will be simply deleted. So it was the algorithm for the push and pop function, that how you can check the state by, if you want to insert an element, so you have to check the state that either the stack is full or not. And if you are removing the elements from the stack, so you will just look at the stack, that check the stack that either the stack is empty. So if it is not empty, so you can delete the elements, but if the stack is empty, so the elements cannot be deleted. So coming towards the code of the stack, which is implemented by using the linked list, it is the same code as we have implement in the linked list code. Here I have create a class of node1, and I will save this file also with node1, and then I will call this file, this CPP file, in another CPP file. So this is also a new method for you. You can also implement code like this. So in this class, this is the class for creating nodes. So I have given it name of node1. Here I have declared a data and the next node. Just like a linked list, that a linked list has a nodes, the node consists of the data and the pointer pointing to the next node. Then in publics, I have make some functions. So the first function is get data, that how you will get data. It will return data for you. Then the set data will assign data. This will assign data, mean this will the pointer will assign data to the node. Then get next, it will give you the next node. Mean if you are deleting or inserting any node, so the next node will tell you about that at which node you are. Then the set next is the next pointer, so it will also tell you about, or if you have insert or delete any item, so it will shift to the next node. Just like push and pop, if you want to insert a new element, so this element will be pointing to the new element. If you want to pop any element, so it will pop the element and the next pointer will be pointing to its previous element. Mean it will be considered just like a top pointer. So here in this file, I have called the previous CPP file, which I have saved with the name of node1. You have to just hash include and close it in commas and just write its name as node1.cpp. And here I have create another class in which I will write the functions for push and pop. Here I have create a head pointer. So the head pointer will change accordingly if you are pushing or popping any elements. So in push, I have passed a variable in data which we have declared in our node1 class. So in this we will create a new node. So this is the code for creating a new node. New node1 mean we will creating this. Whenever we are pushing, so we will create this element and these functions will be creating. So new node1, ask node1.cpp for creation of new node. So the new node will set data. This will assign it a data and a pointer, and as we are inserting a first node, so the head will be assigned to it. And then head is equal to new node, head becomes the new node, and head will be assigned the data. So coming towards the pop, I have declared a h variable. The h is assigned as it is considered. So in this function, we have declared an h integer and then assign the head data to it, as we have assigned in the push function. The last return was head get data, so you have to start from here in the pop retrieving element, that you have to check the last inserted elements, and then a pointer m which will be pointing to the head, and then the head to the next, and then you have to delete that m pointer and return h. Mean in this is the this tell us that address of next node is retrieved and stored as head pointer, because if it is inserting an element, so the head will be pointing to that inserting element. If you are deleting the element, so the item will be deleted and the head will be pointing the last insert. Now coming towards the main. In the main, I have just declare object of name with the name st, and then the push elements into a state by using just, you have to call the push function and assign a node to it, that which number or which element you want to insert. And just like this, for popping, you have to call the function pop. You can call the function pop. I have insert 3 elements by using the push function, and then you can pop and then pop these elements. So the output will be just like this. First the pushing elements, the 5, 6, 7, and then it will be removed in that order. That first the 7 will be removed, then 6, and that at the end the 5 elements. So it was our implementation of states using linked list. The task is you have to implement the state using arrays, and you have to implement the state using arrays and linked list, and but you have to take the values from the user. The user will insert the you have to add an extra function. In the function, the user will insert the elements. So if you have any questions, so we can discuss it in the interactive session, or you can contact me through my email address. Thank you, students.